James Zebo, which is Senior Agriculture Autonomy Product Manager for Hexagon NovAtel. And he's going to talk to us about GNSS. And James, please, could you tell me what's the worst that could happen with GNSS?
Okay.
Does the remote control function? Yeah.
It does. Okay.
Cool.
So a little bit early, but I think we'll be okay. So it's great to see so many people here. This is, I think, my sixth FIRA that I've attended. And it's been humbling to see the progression from academia to startups. And some of those startups are now entering production. And from Hexagon's perspective, you know, that's where we want to be. We want to be helping people take that next step and get their machines into production environments. But what I'm going to talk to you today about is GNSS and what's the worst that can happen. Because even in the last 2 or 3 days, I've seen scenarios where products have been let down because of GNSS, and that should not be the point. That should not be the case. So, a little introduction about myself. I'm a farmer. I come from a farming family in the UK. We have 1,000 acres of mixed arable land. We have 150 rare breed sheep. And in my spare time, I work full-time for Hexagon on their autonomy, agricultural autonomy projects. So who are Hexagon? Well, Hexagon is a very large company that service a number of industries, 25,000 employees in all. Purely focusing on autonomous solutions is approximately 1,500 people. Out of those 1,500 people, approximately 700 are purely focused on GNSS. And out of that 700, there's around 200 people who are purely focused on the agriculture markets. And that is in control systems, and that is in perception systems, and that is in positioning systems. And we answer 3 main problems. Where am I? Where is my machine? And we do that with a very high level of certainty and integrity. The second question we answer is, what is around me? So that's our perception solutions, enabling machines to fully understand the environment that they are operating in. And that's obviously important for safety, but also it enables agronomics and all of the other functions that we've seen over the last couple of days. And the last pillar is, how do I get there, which is the actuation piece. How do I achieve what I want to achieve? So that could be variable rate applications, that could be planning mechanisms, anything that's to do with the action or the outcome of whatever you have decided to do. So today, I only got a short period to talk, so I'm going to focus on the where am I and the GNSS and the positioning side. So the first problem, or the first what's worse that can happen, is actually getting what we call the correction signal down to the receiver. And I'm talking this at quite a fairly high level, because we've got a mixed audience of farmers, academics, as well as robot manufacturers. But I want to point out the problems that could occur. And if you understand what those problems are, hopefully we can mitigate them, reduce the stress, and reduce the pain. So, on its own, GNSS is operating from GPS, GLONASS, Galileo, Beidou, a whole range of different satellite services. But without this correction service, that position is only accurate to 5–10 meters. It's not repeatable, it's not very useful for actuating any vehicle. So you need that correction. And traditionally, that's brought down to the receiver in 2 ways. First, we have a radio RTK system, where we have a base station in a corner or a neighbor's farm, somewhere that's transmitting a radio signal. 450 megahertz is very common in Europe, 900 megahertz in North America and Australia. But when you have an antenna transmitting on an open network, on a system that is free, so anybody can utilize those frequencies, then you have the problem that what's to stop farmer A from transmitting at exactly the same frequency as farmer B, and then you have crosstalk, you have interference. So if you start to see position jumps on a radio network, there is a high probability that you are getting interference from a very similar system operating nearby. Secondly, we have VRS networks. This is where the correction signal is usually received via cellular signal. Like many communication systems, everyone is striving for faster communications. So we have 2G network, which is now used on a lot of IoT devices, fairly slow, low bandwidth. That was replaced by 3G, slightly faster, higher frequency because more data is being transmitted. Then 4G, which is sort of the standard, and now 5G. Every time that we go to another generation, we are operating on a higher frequency because consumers demand higher data rates. But the higher the frequency, the closer that you need to be to the base station, or the closer you need to be to the radio mast, which is very counterproductive for agriculture because traditionally, we are not near base stations or we're not near masts because we could be absolutely anywhere in the world. We certainly cannot rely on population density to provide the telecommunications network. So, traditionally, those two networks could have implications on receiving that correction service. If you don't receive that correction service, then your robot is not going to move. And if your robot's not moving, as a farmer, you're annoyed. An annoyed farmer is going to ring his supplier, his dealer, his support network. They're going to say, well, you're not getting a correction. They're going to get annoyed. Then you've got this whole chain of support from something that could potentially be mitigated. The next possible point of pain in the field is interference. And interference is becoming more and more of a problem the more congested the radio network becomes. The more devices that are transmitting and receiving, the more congested the airwaves become, the more problems or scope for interference we can get. So if you have your radio RTK network very easily interfered with, somebody just tunes to the same frequency, whether it's a taxi company, whether it's a telematics device, whatever it may be, that's going to cause problems. More worryingly, jammers are becoming more common. So think of this use case or this scenario. A truck driver has a tracking system installed on his vehicle. He doesn't like the fact that his manager can see exactly where he is at any one point in time because obviously he's not getting where he needs to be quick enough. And he's gone online very easily for about $15, buys a little plug-in that goes into his cigarette lighter on his vehicle, and that blocks a GPS signal to his tracker. That small device is only transmitting milliwatts, a very small amount of power, and you might think that's not going to have any effect outside the scope of this vehicle. But if we think that the signal that we are relying on from GNSS perspective is coming from over 20,000 kilometers away, passing through space and all space debris, passing through the ionosphere, the troposphere, the atmosphere, passing through Mr. Musk's satellites as well, and then landing onto the ground onto a receiver which is no larger than a dinner plate, the actual power that we are measuring is so small, it can be very, very easily interfered with and very, very easily jammed. So think of this scenario. A truck driver has parked at the end of the field with an ag robot operating. The ag robot's GPS or GNSS system or positioning system goes, hey, wait a minute, my position is compromised, and it stops in the field, like it should. It's not confident on its position, the integrity is dropped, it stops. The farmer gets a notification, poor GPS, poor signal. Okay, so he goes out and has a look what's going on. He can't see anything that's going wrong, he blames the GNSS provider. So he speaks to his dealer being very proactive goes out to solve the problem. Meanwhile, the truck driver's finished his rest, he's driven away, everything's working again. What do you get at the end of it? You get an upset farmer, you get an upset supplier, you get an upset OEM that's built this machine and is having problems. On the next local issue, position spoofing. Now you might think it's very complex to spoof a GNSS position, but thanks to a wonderful game called Pokemon Go, that the open source software is readily available, the transmitters are readily available because the tech community are very lazy, and what's happened is the game was released, people wanted to collect the best Pokemon that are out there, they developed the tools in order to spoof the position on their phone. Again, these tools are readily available on eBay or Amazon, so anybody can start to spoof GPS positions. Now, it seems as though it's fairly innocent when it's in the world of Pokemon Go and gaming, But think of this scenario that somebody is performing a malicious attack or trying to prove a point that they could potentially go near an ag robot and start moving the position that that robot feels that it's in. These are all things that are technically possible. Then we start to go on to the unintentional jamming. Now this is more noise on the machine. An ag robot, very compact, very small, a lot of moving parts, a lot of motors. There's a lot of noise going on, and all this electrical noise could have impacts on the position of the GNSS. So, finally, the intentional jamming, and this really is quite, I don't want to say a naysayer, but this is a problem that is growing. Unfortunately, we are in a world where we have conflicts, and where there are conflicts, is electromagnetic warfare. And electromagnetic warfare does not obey by geopolitical borders and very easily spills into different nations. And we're starting to see effects of this around the globe where jammers, intentional jammers, are actually there operating at an international level causing problems. So it's important that your GNSS provider is able to filter all of these out. So assuming that you've got your position and you're happy with your robot and the way that it's operating, you're happy with your design, part of your process is surely going to be surveying a field or collecting data that you've already captured from somewhere else. And this is where complications can start to come in with actually converting the data between different datums, projections, and even different correction services operate in different ways. So it's a matter of fully understanding where your data is coming from, the format that your data is in, and how that relates to your vehicle operating. An example here may be if you are using a web-based mapping solution where you can see an overlay of a field, where you click that mouse is not necessarily where the actual pinpoint will be on the ground. So mapping providers provide an accuracy anywhere between 2 centimeters accurate all the way to being 25 meters incorrect. So if you start using mapping solutions and clicking your mouse around a field boundary, then you are potentially building a case where your machine is going to go outside of its operational area. So it's very important to think about your processes. So going back onto what's the worst that can happen, well, it's very important to understand the vehicle's position and orientation at all times. So there's the standard ISO 18497 for highly automated agricultural machines. This is a standard which basically says your machine must never go outside of an operating area, a defined operational zone. Now that not only includes the machine, but it includes the implement as well. So let's think of the scenario of an ag robot with an implement that moves back or sticks out 3 or 4 meters behind it. As soon as that machine turns, its implement is also going to turn and potentially go outside the geofence. So it is really important to understand at all times the direction and heading of that machine. And with a single GNSS antenna, that is easily done when the vehicle is moving. But as soon as that vehicle stops moving, you still only have a pinpoint as to what the position is. So you need 2 antennas in order to understand that. And what the 2 antennas does, it gives you a number of advantages, such as the machine being able to operate at much lower speeds and still maintain a very good heading. It also allows that machine to stop. So if we start to think of where ag-robotics could be in 2, 3, 5 years' time, where we have the confidence level to leave these machines in the field for a greater period of time, there may be a change in the weather. So the machine might want to stop, go into an idle state, and resume when the weather condition has cleared. And this could be even for loading up with fertilizer or seed or any other products. So having that ability to safely restart that vehicle because you have a high confidence level in which direction it's facing means that you've got a much more confidence in your system and your machine is never going to violate its geofence. And finally, what's the worst that can happen? Well, functional safety is becoming a very important part of the ag-robotics ecosystem. The industry has passed the point where we can just keep on pushing technology, pushing prototypes. It's got to a point where it has enough attention that industry is watching, that legislative bodies are watching, insurance companies are watching. So what we need to make sure is that anything that goes out into a production environment is safe. And that means that you've got a safe position, meaning you know where your machine is, what direction it's facing with a high degree of confidence. It means that the hardware you have on your machine is either on its own functionally safe or part of a functionally safe system. The standards there are 18497 again and ISO 25119. And that if your system is at part of this critical path, there is redundancy, meaning that if a system fails, there is another one to support it, or that if you have two systems running, that they are both checking and monitoring each other in order to ensure that high degree of integrity. So what do NovAtel do, and what can we do to help in this space? Well, we have a number of products that are able to cope with interference and spoofing. Because we track multiple constellations, we've got a high degree of redundancy in the signals that are coming into the system. And because we have a high number of signals coming in, it is much harder to jam or spoof an individual one of those services. We can provide redundant correction services, and what this means is that you can check that your RTK base station is giving the same position as a PPP-based, satellite-based correction service, and what that means is, once again, you can trust the position of your machine. We provide several algorithms and software tools which allows the machine to jump between all of these correction types in order to keep that machine operating. Of course, as a customer, as an OEM, you can set the boundaries of how willing you are to, or your willingness to reduce the accuracy, for example. But what that means is that you can keep your machine operating for longer. And machine operating for longer means a happier farmer. And finally, we can combine our hardware together in order to get redundancy needed. We've got a number of partners that have got into production with our solutions. They're utilizing our correction services, they're utilizing our hardware, and they're utilizing our redundancy in order to get to their safety goals. So, as I said, hardware can meet the standards of 25119 and 18497. We offer additional value in our solutions with PTP timing and NTP timing. Very important for perception systems, very important for agronomic perception systems. We provide ROS drivers, we provide ROS2 drivers for easy integration. All of our hardware comes with a web interface, which is, if you're an OEM or a manufacturer, allows you to do remote support and remote diagnostics. Our receivers have the ability to fuse IMU data to provide an INS solution, and what that means is if your machine is passing under trees, for example, that it can maintain a global position without just stopping. And that, again, means more uptime for your machine, which means happy farmer. And finally, the heading calculations and the heading algorithms mean that you've got a very good, good idea of what direction it's heading. So the products that answer the question, where am I? Primarily today we're talking about two products, the Smart 7 and the Smart 2. And when they're working in combination with you and each other, they provide protection and assurance against all of the potential threats and problems that I've identified. So, like I said at the beginning of the presentation, we are dedicated to agriculture. Agriculture is a big part of what we do. We'd like to see OEMs go from that startup through to production, and we're there to help with these products ready to go. For those that are more mature with their products, the contents of these smart antennas are available at board level. So when you get to the point of cost optimization, then we have a product for you as well, which meets all of the same criteria. So going back to the original three pillars, where am I? what's around me, and how do I get there? I've very briefly answered the where am I. If you want to talk about some of our perception solutions and products, please do come and see myself. Or we've got a number of guys here from Hexagon. We've got Christian, we've got Alistair, we've got Alex, we've got Heather, we've got Core. So we've got a number of guys here. We're walking around the event. Please do get in touch. So on a final note, we are recruiting. We're recruiting engineers. We are recruiting sales team. We are recruiting a number of roles across the globe. If there is anything that you might be interested in, please do just get in touch with us.
Many thanks, James. Well, again, fascinating. Thank you very much for this presentation. Question. First, you're recruiting. There is a university just behind us with high school degrees in agronomics and culture. Have you seen them? Have you met them already?
I have not, but we are actively looking for a multiple range of individuals, whether that is just entering as essentially an apprentice level, all the way to senior management. So we are expanding very quickly, and we have a lot of roles to fill.
Okay, really nice, because we have to introduce you to the network of university, especially around there. Just to remind you, in Toulouse, we've got in Occitanie, which is a region where you are, we've got 8 universities of high degrees about agronomics, but we've got engineers as well for techniques, technologic things, IA, and I see the next one who coming here, the brilliant, the fabulous Thierry Chapuis, who is as well an engineer from the CNES, who will talk about that. But of course, if you're recruiting, we need to talk with the FIRA to give you the network of students here. Thank you very much again, James.